You know, some numbers are just kind of weird. And for my money, 19 is definitely on that list. It's prime, it doesn't seem to have any easy shortcuts, and it's just stubborn. But today, we're going to peel back the layers on this curious number and find a really elegant strategy hiding inside.
All right, let's kick things off with a little challenge. Here's a number, 5,128. Now, without grabbing your phone, how would you figure out if it's a multiple of 19? I mean, you could do long division, but really, who has time for that? What if there's a better way?
And yeah, of course your phone knows the answer in like half a second. But that's not the point, is it? This isn't just about getting an answer. It's about the fun of the process, about playing with the numbers and seeing the cool patterns they hide. So to do that, we're not going to just memorize some boring old rule. No, instead, we're going to build what I like to call a number machine. It's a strategy that takes a big, clunky number and shrinks it down over and over into something way more manageable. So what's the secret sauce here? Well, believe it or not, the key to understanding 19 is its next-door neighbor, 20. The fact that 20 is exactly one more than 19, and that it's a nice multiple of 10, well, that's the whole foundation for what we're about to do. And here it is, our number machine. You feed a number into the top. The machine tells you to take the very last digit, double it, and add it back to the rest of the number. This spits out a brand new, smaller number. And here's the cool part. If your original number was divisible by 19, this new number will be 2. Let's see how it works. Okay, let's grab a number, say 437, and feed it into this thing. First, we just split it in 2. We'll call the number without the last digit A, so that's 43. And we'll call the last digit itself B, which is 7. Pretty simple, right? Okay, let's turn the crank on the machine. Step 1, we take that last digit, the 7, and we double it. That gives us 14. Step 2, we add that 14 back to the rest of the number, the 43. And 43 plus 14 is 57. Just like that, our machine turned 437 into 57. Now here's the really cool part. The machine promises us that if 43(7) is a multiple of 19, then 57 has to be 2. Now you might already know that 57 is 3 times 19. But what if you don't? No sweat. The best part about this machine is you can just use it again.
So round 2. Let's put 57 back in. This time, A is 5 and B is 7. We do the math. 5 plus 2 times 7, which gets us
19. How cool is that? The whole process led us right back to 19 itself. And since we know for a fact that 19 is divisible by 19, that means our original number, 437, was a multiple of 19 the whole time. Pretty neat, huh? But why? How does that even work? It kind of feels like a magic trick. Is it just some weird coincidence? Well, no, of course not. This is math, and there's a really beautiful, logical reason for all of this. It's time to look behind the curtain. Okay, don't let the big words scare you. The idea behind this is called modular arithmetic, but really, let's just call it the remainder game. All it means is that we only care about the remainder after dividing by 19. If two numbers have the same remainder, we say they're the same in our game. And inside this remainder game, there is one single golden rule that makes our whole machine work. If you take 20 and divide it by 19, what's the remainder? It's 1. So in our game, the number 20 and the number 1 are basically the same thing. They behave the same way. This right here is the key that unlocks everything. Whoa, okay, lots of letters and numbers on the screen. Don't tune out. I promise, we're going to break this down step by step, and it's actually way simpler than it looks. First thing you need to know, it's totally okay for us to take our big number, we'll call it n, and multiply it by 2. Why? Because 19 and 2 are prime to each other. They don't share any factors. So multiplying by 2 doesn't change the basic answer to our question. Is this thing divisible by 19? Okay, here comes the big move. We can write any number as 10a plus b, right? So 2n becomes 20a plus 2b. But wait, remember our golden rule from the remainder game? In the world of mod 19, the number 20 acts exactly like the number 1, which means that 20a acts exactly like plain old a. And there you have it. In our remainder game, 20a plus 2b is the exact same thing as a plus 2b. That's the proof. It shows that checking our original big number is the exact same problem as checking our new smaller number. It's not a trick, it's a beautiful, logical shortcut. So what's the big takeaway here? This was never really about memorizing a rule for the number 19. It's about looking at math as a kind of creative play. It's about seeing a problem and asking yourself, is there a more interesting or elegant way to think about this?
So let's just run through the highlights real quick. 19 is prime. The whole strategy works because its neighbor, 20, leaves a remainder of 1. You can keep running the machine over and over again. And if you end up with 19, or even 0, you know your original number was divisible.
And let's be real, nobody's saying you should throw out your calculator and do this every day. That's not the goal. The real point is to give your brain a fun little workout and to just stop and appreciate the incredibly elegant patterns that are hiding inside numbers all around us. Ultimately, this whole curious case, this entire clever strategy, it all just boils down to one simple recipe. Drop the last digit B, double it, and add it to the rest. That's it. A plus 2B. Which kind of leaves you with one last question, doesn't it? We've uncovered one of 19 secrets. But what about 23? Or 29? Or 47? What other amazing patterns and clever strategies are just sitting there, waiting for us to find them? The real fun is in the search.